Good afternoon, everyone. All right, so with respect to algebra, there are two main categories that we're going to look out for. There are others because there's like substitution and so on. But what I'm going to look at is simplifying and solving. Good afternoon, Rebecca. All right, so what we're doing is we're just going to go over algebra first, because the question that we had last week, there was a little algebra in it, right? So I just want to make sure that we're clear on algebra first, because as you know, the paper 3, you're being tested on everything. So I just want to make sure that you're comfortable with all of the topics so that as we introduce the paper 3 questions, it makes it easier for us. So algebra, there's simplifying and solving. Now, how do we know the difference between simplifying and solving algebraic terms? Now, the difference is that when it's simplifying, there's no equal sign. While on the other hand, when it comes to solving, there is an equal sign. Now, with respect to your simplifying, we have to be able to group like terms we must be able to expand to get rid of brackets. Right, so we must be able to expand to get rid of brackets. We're going to have rules of indices. Good afternoon.
Afternoon.
Good afternoon. All right, so what we're doing is one of the questions that we looked at last week in the paper 3, it had some algebra with it. So what we're going to do is we're going to just go over algebra, make sure that we're clear on it, so that when we go back into our question, it's going to be easier. Now, to know the difference between simplify and solve, simplifying, there's no equal sign. And basically, all you're expected to do is just to break it down into the simplest form possible. You wouldn't get a value for the x or anything like that, because it's not an equation. Solving, on the other hand, there is an equal sign. When it comes to simplifying, you're going to see the term expression. An expression does not have an equal sign. While in solving, you're going to see the term equation. equations, there are equal signs. Now, for simplifying, we have to know about grouping like terms, expanding to get rid of the brackets, rules of indices. Same thing with solving. You also have to group your like terms, expand to get rid of your brackets, and also you have to know your rules of the indices. Now, in simplifying, let's say we were looking at grouping like terms. Now, what you have to know is that a term could be a number alone, it can be a letter alone, or it can be a letter and a number. So anytime you hear the term or the word term, it could be one of these three types: a number alone, a letter alone, or a letter and a number. Now, for a letter alone, it might be like A, X, Y, but if it's a letter alone, it's understood that it's one A, one X, one Y. Or it could be a number and a letter, such as 4A, 2X. But what this actually means is 4 multiplied by 8. And this actually means 2 multiplied by X. So anytime you have a number and a letter or two letters together, it's understood that they are multiplying in between. Now, grouping like terms. Now, when it comes to grouping like terms, we have to understand that numbers and these terms, they have their bags, right? So when we speak of numbers and terms, meaning with a letter alone, with a letter and a number, or a number only, we have to understand that all of them, they have a baggage. So let's say they gave us something like this. if they gave us something like this, two things we have to note. Numbers or terms, they always carry their sign in front of them. So they could either be a positive or a negative number or term. And their sign is always in front. That's one. And two, algebra likes organization. So you see how you have y over here and y over there, or x over here and x over here. Algebra is pretty organized, which means it likes everything in one place. So how we have y here and y here, algebra, when it asks us to simplify, it's expecting us to bring all of the like terms together. Meaning, if they're the same letter, we bring them together. If they don't have a letter, we bring them together. Now, first thing we do is you could box everything with your sign in front of them. Now, this negative sign belongs to the 4x. This plus belongs to the 6y. This negative belongs to the 2x. So you might be wondering, what belongs to the 3y? If there's no sign in front, we understand that it is a positive. Right? So if it doesn't have a sign in front, we understand that it's a positive. So you want to bring your like terms together, all the y's together, all the x's together, all the numbers without a letter, and so on. You put those together. So I'll have 3y plus, I put any y's together, plus 6y minus 4x minus 2x. Now, this part actually gives most students trouble. And the reason why is because your sign, it comes like this. Joshua, you're going to it. You will move with your bag. If they ask you to move, like let's say they ask you to move from one department to another department, you don't mind moving once you move with your bag. However, they tell you, okay, Joshua, leave your bags in this department and head on to another department for the rest of the day. Now that will cause some trouble because you like to move with your bag. So it's the same thing with your numbers and your terms. They don't mind moving anywhere. Once you move with your baggage, which is your sign in front of them, right? So your numbers, your terms, you can move them anywhere you want once you move them with the sign in front of them. Now, another thing that you must be able to apply is your rules when it comes to directed numbers, meaning positive and negative numbers, right? So you must know these rules. If it says that you're adding and subtracting, right? So that's when adding or subtracting. I better put the word. Right, so when adding and subtracting, we have two rules. One, if we have two same signs, right, so if we have two same signs, the rule is we add like normal and keep the sign. Second, if we have two different signs, your rule is we subtract and keep the sign of the larger number. Now, if you don't know these rules, you need to know them by heart because you know how salt is in food? It's in almost every dish. These rules comes like the salt in your food in math when it comes to mathematics. It's in almost everything. Right? So if we have two same signs, we add and keep the sign. If we have two different signs, we subtract and keep the sign of larger number. So look at this. We have two same signs. That's 3y plus 6y. That's 3 plus 6. That's 9y. Look at this one. We have two same signs. Same thing, you add like normal. 4 plus 2, that's 6x. But you keep the sign. So it'll be minus 6x. Now, think of your letters as though they are objects. If y is apples, 3 apples plus 6 apples, we could add those. And let's say x is grapes, 4 grapes and 2 grapes, I can add those. But I can't add apples to grapes because they're too different. Same thing when it comes to algebra. I can only add or subtract like terms. Now, another set of rules we must know is when multiplying and dividing. Now, the rule is you're going to multiply or divide like normal. If you don't know these rules, we are going to have a little trouble because everything is based on these rules. Right? So we multiply or divide like normal. One, if you have two same signs, answer is positive. And if you have two different signs, answer is negative. Now let's give some examples. So they gave you -3 times -4. You multiply like normal. 4 threes are 12, but once you have two same signs, answer will be positive. So to be positive 12, but I don't have to put the plus sign because it's understood. If I had -6 times +2, multiply like normal. 6 twos are 12, but because one is positive, this one has no sign in front. So it's understood to be positive. Numbers are always either positive or negative. So because I have two different signs, your answer will be negative. Same for division. You divide like normal, but if you have two same signs, answer is positive. If you have two different signs, answer will be negative. Now, with respect to expansion, so this one was grouping like terms. Expansion is going to use this rule. Now, expansion, it deals with brackets. So they might give you something like this. Now, by the distributive law, when I expand this, whatever is outside, I'll multiply by everything inside. But you must remember your rules when multiplying with positive and negative numbers. So 2 times 4x, 4 twos are 8x, 2 times 2, that's 4. If they gave us one like this, so -6 by 2x minus 3. Now, anytime you deal in algebra, what you can do is you can box everything with a sign in front of them. It makes it a little easier to see. Remember, if there's no sign in front like this 2x, we understand that it's positive. So whatever is outside in algebra, we do like if you have brackets, we don't work with the brackets. We want to get rid of those brackets, so we're going to expand. Whatever is outside, we multiply by everything inside. So 6 times 2, you multiply like normal. 6 twos are 12x, but I have two different signs. So it's going to be -12x. 6 times 3, multiply like normal. 6 threes are 18, but when you multiply, you have to consider your sign. A lot of students get trouble with this part. So it's a negative by a negative. Once you have two same signs, your answer will be positive. Right, so we must remember these rules. When you're expanding, when you have brackets, get rid of your brackets. If you have like terms scattered across the equation or the expression, you want to put all your like terms together. Another thing that we must know from these positive and negative rules is that if you have two plus signs back to back or two negative signs back to back, they're right after each other, you can replace them with a positive sign. So once you have two same signs, you replace them with a positive. If you have two different signs back to back, and I'll show you what I mean, you replace it with a negative. Now, if you are having trouble with these rules, make sure that you learn them off to the back of your hand. All right, so let's see. Let's say they gave you something like this. Now, anytime you have two signs back to back, these are the rules that we have to apply here. So it's basically you're going to replace the sign with the sign that it results in. So you have two different signs. So because I have two different signs, it's going to be negative. So it becomes 2 minus 8. So if we have something like this, one is positive. Remember, we carry our bags on our back, but numbers carry their bags in front of them. All right, so it's always in front. If there's none in front, we understand that it's positive. So you simplify when you have signs back to back, and then you could apply your rules when adding or subtracting, and so on. So for this one, I have two different signs. So we subtract like normal, 8 take away 2 is 6, but you have to keep the sign of the larger. So that's negative 6 in this case. So in mathematics, your positive and negative numbers rules we must work with these. We must do them. If we don't, we're in a bit of trouble, right? And it's not late. We could practice them, right? But please practice them. Please know your rules. Please look out for them, especially in algebra. All right. So I'm going to pause the video again. All right. So next up, solving algebraic terms. Now, everything that you've done with simplifying, you have to remember it with respect to solving as well. All right, so solving algebra. Now, one, every rule that we've just done with simplifying with respect to grouping like terms, expanding to get rid of brackets and so on must be applied. Now, when it comes to algebra and solving, there's always an equal sign. Your goal in solving algebraic terms is to get x or whatever letter is equal to something. You want to get x alone on one side of the equal sign. And what we can do is we can put all the x's on one side and all the numbers on the next side. Now, think of your equal sign as a portal. Now, when I say the equal sign, it can also work for inequality signs as well, okay? So you're doing the same thing for inequality signs as well. I only introduced this because in one of the questions, there was an inequality that we had to solve. So when I get to that practice question, I just want to make sure that you guys note the same thing we're using for this one of the equations, we're going to apply for the inequalities as well. Now think of your equal sign as a portal where once you cross the equal sign, you change the operation. So if something was adding, the opposite will be minusing. If something was minusing, when I carry it across, it becomes adding. If something was multiplying, when it goes across, it's going to be dividing. If something was dividing, when I carry it across the equal sign, it's going to be a multiplication. Square roots, sorry, the square, the opposite will be square roots. Square roots, when I carry across a square root sign, it becomes the square. So think of your equal sign as a portal. Once you cross it, you perform the opposite operation. So I'll do a simple one and then a complicated one, and then we move on. So let's say they gave you 2x plus 3 is equal to 9. Now in algebra, what you can do, if it's confusing for you, think of, remember your goal is to get x on one side. So I want to carry everything else across the equal sign. So I'll have x alone on one side and a number on the other side. So because we're looking to move, if you're looking to move, don't you pack stuff? So because these numbers are looking to move, why not pack them with their luggage? Remember, their luggage is their sign in front of them. And if there's no sign in front of them, we understand that it's a plus. So you start with the one that is further away from the x, which is this one. I'm going to carry it across the equal sign. But once I cross the equal sign, I have to perform the opposite operation. So I'm going to take a 3, bring it across, but because it was adding, the operation changes. It's not a sign, and I'll show you what I mean when it comes to division and so on. So when I carry this across, it's going to become -3. Now, if you're in a food line and you cut a line, so like, you know, normally in food places, if one line is too long, they might cut it and say, okay, everybody from here come across on this side or whatnot. Now, if somebody come and cut in front of you, that's trouble. So the numbers is the same thing. If the 9 was in front and you're bringing across the 3, you put him after the 9. The 9 was there first. If you put it in front, especially if it's division, you're going to have some trouble with your answer. Right? That's just one way I like to help students remember this part. So you solve, so 9 take away 3, that's 6. But I want x alone. Remember, your goal is to get x alone. So I'm going to bring across the 2. But remember, anytime you have a letter attached to a number, it's understood that they are multiplying. So when we carry it across the equal sign, the opposite of multiplying is dividing. Remember, I told you it's not the sign that changes, but the operation. That's what I mean. I mean, this here is a positive 2x. But the operation it was performing is multiplication. So when it goes across, it's going to become divided. Now, Rebecca, the 6 was there first. So put him back first in the line, and then you put the 2 after. So it'll be divided by 2. X is 3. Now, algebra becomes easier with practice. And once you know all of the rules collectively, right? So like you see how we went through everything that you need to know, it makes it easier for you. Let me show you another one. All right, so let's look at this one. Let's say they ask us to solve this one. Now in solving this, you have brackets. Algebra doesn't do too well with brackets. So we want to free our numbers. And in order to free our numbers, whatever is immediately outside, we multiply by everything inside of your brackets. Remember, you have to apply your directed numbers rules if you have positive and negative numbers. So 3 2s are 6x, 4 2s are 8. There are 2 positives, so it'll be positive 8. Now, algebra, I put in an extra equal sign. That's not supposed to be here. There's only one equal sign. Algebra, in solving, it wants x alone on one side. So if I look here, I have x on this side, x on this side. You could box up everything with your sign, but remember your goal is you want all the x's on one side and all the whole numbers on the next. So I'll end up with 6x. I'm going to bring across the 2x. Now it was adding. So when it comes across, it's going to become minus 2x is equal to, I'm going to carry across this 8. It was adding. So when it goes across, it becomes minus 8. So putting all the x's together on one side and all the whole numbers together on the next. Then we Simplify further. 6x minus 2x, that's 4x, is equal to negative 8. But I want x alone. So I have to get rid of this 4. It is attached to the letter, so that means it's multiplying. So when it goes across, it becomes the opposite. 8 was the negative, 8 was there first. So when I carry across the 4, it was multiplying. So when it goes across, it's going to become divided by 4. But you could write it like this, or you can write it like this, divided by 4, same thing. Now, 1 is negative, the 4 here is positive. You divide like normal. 8 divided by 4, that's 2. But once you have 2 different signs, it's going to be negative 2. So in solving algebra, your goal is to get all the x's on one side, all the whole numbers on the next. Think of your equal sign as a portal, where once you carry them across, these operations across, you perform the opposite operation. All right. So what we'll do is in the next class, we're going to go back into the question that we saw. But I just need you guys to practice these, and you can practice it with your past paper questions. Right? You can't do it with your past paper questions. All of your algebra goes through for the algebra, solving the algebraic sums, etc. Practice them, practice them. All right, so I'll stop the video for now, but please don't go. I'm not finished as yet. All right, so I'm stopping the recording.